Good morning, everyone. Welcome to another First Flight brought to you by Courthouse/Cyphrin. Hope you are doing well, and let's get started. This time we have a really interesting project because we have kind of recycled one of our old First Flights, but brought to you in a different way. So let me share my screen to get started, and I will explain you how to clone and run this project. So let me just go to present. Okay, let's see here. This first flight number 11 is called Snek-Raffle. Remember our first flight number 2, Poopy Raffle, on which you can enter with an entrance fee and then be able to earn a NFT, a random poopy NFT. Well, we took the same inspiration, the same idea for the poopy raffle, and we transform it into a snake raffle. And the reason we are using the snakes is because this project is meant for you Pythonistas, because here we are not going to use Solidity, but Viper, which, as you might already know, is based on Python. This is a really interesting project because, again, it's a different programming language, but also because we are going really experimental on this one. The reason is because Viper by default does not support imports. You need to manually take any smart contract you want to use from outside and add it manually to your code repo. However, since the last version of Viper, we are able to do some sort of importing using like pip3 install and using the GitHub repo for that. So for this project, we are actually using this repo called SnakeMate, which is a standard implementation of some smart contracts like the ERC721, which is the one we are going to be using for this project, or in other words, a standard NFT smart contract implementation, but for Viper. However, I must say that the only thing you need to audit, the only project on the scope, is the Snek-Raffle.by. All the imports from this repo are not on the scope, and we are trying to assume that the original repo from where we are importing works properly. So let's go through the actual contract, and then I'm going to go through the cloning slash installation and slide troubleshooting of this first flight. Normally, I get for granted that all of you know how to clone and start a project using Foundry or maybe Hardhat, but as this is a Viper project slash context, I'm going to get a little bit more into the details on how to make this project to run. So let's take a look on the description of Snek-Raffle. Again, for those of you who have already participated on the Poopy Raffle contest, the functionalities are actually the same. You can enter to this smart contract with the entrance fee, and then a random winner is selected. That random winner is able to mint a random NFT, in this case, 3 different snakes. These ones over here. So that's it. The random winner is selected using Chainlink BRF. BRF is the way Chainlink selects a random number, but it's a truly random number. You know, when you are using random numbers on your console, let's say, they are not actually random, they are pseudo-randomic, because what the computer does is it takes a space on memory. It says, okay, this is random enough, and that's it. But all that information can be manipulated. That's why you have solutions like Chainlink BRF Please, if you haven't used Chainlink BRF before, go and check the documentation, especially because Chainlink BRF has two methods, the subscription method and the direct funding method. On this project, we are assuming that the subscription method has enough funds. However, I'm going to explain some other things later. And also, if you haven't ever used the get random number, go to the Chainlink documentation and take a look. The example provided by Chainlink runs on Remix slash Solidity, but it will help you to understand the basic functionality on how Chainlink BRF gets a random number. This is going to be important because, as I said, our first flight project used Chainlink BRF to select a random winner. So let's go to the functions. First, we have enter raffle, user pays an entrance fee, as I already said, to enter the Snek-Raffle. Request raffle winner, this function uses the Chainlink BRF to select a random winner. The, um, the contract state must be to open, or the raffle state must be open. It must have the enough raffle duration has passed since the raffle was opened. This duration is based on the block timestamp, so you cannot enter the lottery or the raffle and select a winner right away. You need to wait till some time has passed before you can select the random winner. There is at least one player and there is more than zero balance in the contract. You cannot mint something if you don't have any balance of it. Then we have the raw fulfill random words. This is the function that is actually a requirement by Chainlink BRF. This is what calls Chainlink BRF to get that random number and then selects the random winner. And once this process is done, the contract is going to reset. The raffle is considered open. The player array is reset. And the last timestamp is reset. This is just like, okay, we have a new winner. Then all these state variables are reset to their defaults. Again, this is an NFT. You might be able to use this NFT as you should, as you were on any other like Solidity ERC 721 with the ability to view, transfer, and proof, and etc. As I said before, we are just considering in the scope the Snek-Raffle.buy. We are getting for granted that the ERC 721.buy, which is provided by the SNECmate, works properly. If you find some sort of error on the import over this repository, don't pay attention to it. Just focus on the Snek-Raffle.buy, which is the scope of this smart contract. Well, let's get started. First, the only thing I'm going to get for granted is that you already have Git and Python and pip installed, which is the basic Python stuff libraries that all developers must have. And then let's get started with the actual process on this project. First thing first, let's clone this repo. So copy, let's go to my terminal and paste it over here. This shouldn't take that much. Let's enter that project. And here we are going to need and use a VMB or Python virtual environment. The reason is because when you start installing libraries for Python and the projects you are working with start to mixing with each other, you might encounter a lot of errors because some libraries have some sort of incompatibilities with each other. So the best way to manage a Python environment is to create an isolated box on which you are going to install just the dependencies you need for that project. This project already comes with the instructions to create, activate, and install those dependencies. However, if you haven't used a Python virtual environment ever before, I highly recommend you to click on the Codehouse documentation here and learn more about BMB. Let's continue. So I'm going to just make BMB, go back to my terminal, paste it over here, and I'm just going to keep copying and pasting the provided commands. The next commands is to activate that new created BNB. As you can see here, it's going to appear as this new Python virtual environment I just created. And here I'm going to install the dependencies. This project has a make file, so you can just type make install, and this is going to install all the dependencies for this. Let's wait a second. Okay, we have a question here. I've never used a virtual environment for Python. What's your opinion on Conda? Conda is great, however, is harder to manage because Conda is meant to be used for machine learning slash artificial intelligence stuff. I'm not saying you cannot use it for these more um, different developments, but for smart contract development, at least personally, I recommend using or BNB or virtual env packages because Conda is an entire suite of tools for development, and they are more focused on, as I said, machine learning. You have libraries like Pandas, Matplotlib, Scikit-learn, etc., etc. Let's continue because my terminal already finished it. So let's clear my terminal. And once I have this, I must be able to run everything, right? So let's run a Viper contracts Snek-Raffle, which is the contract I have here. If you don't know why I'm doing this, you are going to find the exact same on the documentation. So if I take a look here, as you can see down here, you can manually compile using Viper contracts Snek-Raffle. So I'm going to do the exact same. Let's hit enter, and this is going to generate a long hash number, meaning that the project was completed successfully. Something that you might notice and some trouble you might find is that these tests are built or written on PyTest. So if I run just PyTest over here, this is going to probably give me an error like boa.contracts viper doesn't have this functionality. The reason is because PyTest is a library which already comes pre-installed with Python. So if I type which PyTest, this is going to be using the local installation of PyTest and not the one on my virtual environment. So to solve this, I just need to type Python 3 -m PyTest. This way, I'm going to use the actual environment. And as you can see, the test now works as expected. Just as a recommendation for you, if you are going to clone this repo and you have problems with your Python environment, first be sure you are using the correct Python installation. If you type which Python, this is going to be pointing you to the Python you are using. As I said, you need to install a virtual environment. So this is using the virtual environment inside my project. If you type which Python, let me actually show you on another terminal. If I type here, a second, let me make this. Oh, what the hell happened? Give me a second. Uh-huh. Sorry, I opened the magnifier. Okay, let me clear the terminal. If I type which Python here, I type Python incorrectly, Python 3. Yeah, as you can see here, it's going to show user being Python. As this Python doesn't have the dependencies needed for this project, you might probably encounter more problems. So be sure that for running all the dependencies and all the commands for this specific audit, to be using this virtual environment, which already comes on the instructions. That's it for the setup part. But let me open a little bit this. So let me code open and guide you through some of the basics of this smart contract written in Viper. First thing first, remember to go to the extensions and type Viper and install the Viper extension because this is going to allow you to have syntax highlighting for the Viper language. We always recommend to use Visual Studio Code. And if you're not using Visual Studio Code, you should. I don't have actually a good answer for that because we don't use that much other code editors, but I hope there is at least some extensions for other code editors for Viper. Also, remember to have the Python extension installed as well for the project to be able to read and run this. So let's go to the contracts and let's go to the Snek-Raffle.by. This is the scope of the project. Don't worry if you haven't used Viper before, because it's based on Python, and Python, even if you haven't used Python either, is really easy to understand if you already know how to code. Basically, we are going to use this from libraries .snake made tokens. Remember, I said that the latest version of Viper supports importing. So this is just importing from that snake made, and we use these exports to take that ERC721 functionalities. We have some error declaration, a flag. This flag is the same or similar to an enum in Solidity. We have some constants, and we have things like this one, number of random words. This is for the chaining BRF. So again, if you haven't used BRF before, please check the documentation, because these constants and these, for example, constructor variables over here, like the BRF coordinator, is going to make a lot more sense for you. Something you might pay attention to is that BRF is an external Oracle service. It means that you need to deploy this contract to a live network. It could be a test network like Cephalonia, and then pay all those transactions in order for BRF to actually generate a random winner. You know that this is not optimal because it requires a lot of time and you need to start deploying and redeploying test contracts to a test network. So this contract comes with a BRF mock. If you don't know what a mock is, this is like a fake smart contract which is going to act as it were BRF, and is going to generate a pseudo randomic number in order to get like that random winner. This is helpful because you can run this locally and you don't have to worry about, deploying the whole smart contract to actually test how that works. Also pay full attention to the test folder. Again, standard Python testing with some caveats because we are using the BOA library, but these are like the test to ensure all the function works as expected, especially the test fulfill random works, picks a winner, resets, and sends money. I would pay a lot of attention to this function if I'm auditing this smart contract. What else? If we go back to the contract, we have the functions I described before. We have view functions, like just to get information, and this is the fulfill random words. These words, this works especially in conjunction with BRF. So again, please do check the BRF documentation before you start auditing this, because otherwise this code is not going to make any sense to you. And I think that's it. This is like more or less the explanation of how it works. I hope you enjoyed my explanations about this project. It's really different because we are not using Solidity, but Viper instead, and we are going really experimental, as I already said, because we are using the latest Viper version, which allows importing. So it might be tricky to handle a project like that because there is not enough documentation yet and not enough projects out there using these experimental features. But we like to challenge you to do it anyways. You are going to learn a lot. Remember that knowing just one programming language as a smart contract developer or auditor is not enough. Always having a backup language is needed, and Viper is an excellent one. So this will hone up your skills as an auditor. Remember that first slides are our effort to take newcomer slash not that experienced auditors and give them the opportunity to experiment how to audit actually work, how a competitive audit actually works. You can earn experience from this audit, and I hope you submit some nasty bugs and vulnerabilities. That was it for me. Thanks for watching. If you are watching this asynchronously, please remember you can always contact us on Discord and ask any question, and we will glad to help you over. Thank you very much, and I'll see you on the next occasion. See ya.